Alright, so in that video, let's talk about payoff dominance and risk dominance. And the concepts of payoff dominance and risk dominance have something to do with stack hunt games, where we are interested under which conditions certain equilibria are more likely to emerge. So let's take a look again at the stack hunt game. Let's say we have two firms, firm 1 and firm 2, and they can either play aggressive or moderate. So if we play that game and we put ourselves in the position of firm 1, and firm 1 thinks that firm 2 plays aggressive, then shall firm 1 play aggressive or moderate, and of course 5 is better than 0, so we underscore the 5. And so we underscore the 5. And if firm 1 thinks that firm 2 plays moderate, shall firm 1 play aggressive or moderate? Well, in this case 8 is better than 7, so we underscore the 8 for moderate. So now let's play the same game for firm 2. If firm 2 thinks firm 1 plays aggressive, shall firm 2 play aggressive, get 5, or moderate, get 0? Of course 5 is better. So we underscore firm 2's aggressive strategy with the 5, and if firm 2 thinks firm 1 plays moderate, shall firm 2 play aggressive or moderate, and in this case moderate would be better because 8 is bigger than 7. Okay, so we can see we have two Nash equilibria, and one is 5-5 and the other one is 8-8. So earlier when we talked about coordination games, we said that payoff dominance is a good predictor for the emergence of the moderate equilibrium. But that doesn't have to be necessarily true, because very often, especially like in conflict studies, we can actually observe that the conflict or aggressive equilibrium is very persistent. So in order to understand that, we need to introduce some theories and also some new vocabulary. Okay, so if we take a look at this game again, so we have the two equilibria, aggressive and moderate. And obviously, or clearly, we would say that the social optimum is moderate with an aggregate payoff of 16. So it is Pareto superior, or it is payoff dominant. So the payoff dominant strategy is obviously 8-8. The interesting case now emerges that we still may observe cases in which aggressive is so dominant. So what we need to do is we need to better understand what's actually happening in the aggressive equilibrium. So if we think of the aggressive equilibrium, then, and we compare it to the moderate equilibrium, what we can see is that if something goes wrong in the aggressive equilibrium, an individual player can lose a lot. So if, for example, firm 1 and firm 2 are currently in an aggressive equilibrium, but firm 1 accidentally plays moderate, maybe because there's a new management that does unexpected things. Well, in this case, it may lose 5. And because the game is symmetric, the same applies if, let's say, firm 2 accidentally miscalculates its move. So the worst case that can happen in the aggressive situation is a loss of 5. Well, in the equilibrium of moderate, not much can happen. So the worst thing that can happen is, let's say, if firm 2 miscalculates and plays instead of moderate aggressive, it will lose only -1. And likewise, firm 1 would only lose -1 if they played aggressive instead of moderate. So I think it's pretty clear that the worst, if something goes wrong, the greater damage occurs in the aggressive equilibrium, and that is one of the reasons why we call the aggressive equilibrium risk dominant. But this was just an intuitive interpretation. There's actually a more formal way to identify risk dominance, and those 3 ways are called the coin flip test, the Nash product test, and the Besson of attraction approach. So let's take a look at the coin flip test. So we have again here the game. And the coin flip test simply assumes what happens if all the players play their strategies with a probability of 0.5. So both players, the coin flip test assumes that the 2 players play their available strategies with equal probability. Every strategy is played with a probability of 50%. So then, what is the expected payoff? Well, if we compare for the aggressive, so let's take a look at firm 1. So the expected payoff for firm 1 when it plays aggressive is now 5 with a probability of 0.5, and of course that is because firm 2 plays aggressive with a probability of 0.5. And maybe just to do it again like we did before, the 0.5 comes from player 2 in this case. Okay, and then it gets 7 with a probability of also 0.5. So the expected payoff for firm 1 when it plays aggressive is 2.5 plus 3.5, which is 6. And you see we have already that here. So if firm 1 plays aggressive, can expect 6. If it plays moderate, it can expect 4. How do we get that? So then, play moderate, you get 0 with probability 0.5 and get 8 with probability 0.5. So the expected payoff is 4. And because this is a symmetric game, this is true. So the 6-6 associated with aggressive corresponds to the 6-6 associated with firm 2 when firm 2 plays aggressive. And likewise the 4-4 when firm 1 plays moderate. Can also be seen when we look at firm 2 moderate strategy. Because it's a symmetric game, the payoffs are the same. So for firm 2, we put the expected payoffs vertically. For firm 1, they are in the row. Okay, so in this case, the coin flip test says the risk dominant strategy is the one that has the highest expected payoff in the coin flip test. So in the coin flip test, the aggressive has a higher expected payoff, and therefore it is considered to be the risk dominant strategy. Risk dominant again meaning more bad things can happen. So now let's take a look at the Nash product test. That's actually easier. It's closely related to what we already did. It just takes a look at the product of what can happen in each equilibrium. So if you take the aggressive equilibrium, the worst thing that can happen is that firm 1 drops from 5 to 0, and firm 2 also drops from 5 to 0. So now we multiply those losses. So we do 5 minus 0. So that is 5, and then we multiply that for the maximum loss of the other player. So that gets 25 for aggressive. So that is the product of the worst case scenario, the product of the losses if something goes wrong in aggressive. So that's 5 times 5. And if that is greater than the loss associated with something going wrong in the moderate equilibrium, so it could be either a loss of 8 to 7 for firm 1, but also a loss of 1 for firm 2. So here we have only 1 times 1. Okay, so here we have to the left 5 times 5, that's 25. And that's the, how shall I call that, maybe the worst case product in the equilibrium aggressive. And that is greater than the worst case product in moderate. So whatever is the higher product, that is the risk dominant equilibrium. So the final approach is the basin of attraction approach. And what we need to do here is we need to ask the question, what has the higher basin of attraction? So let's say we want to calculate the probability when aggressive is more attractive in a mixed strategy game. What is the threshold when aggressive is more has a higher payoff than moderate? And for this case, we assume that both firm 1 played that strategy aggressive with probability P and moderate with 1 minus P, and also firm 2 plays aggressive with probability P and moderate with 1 minus P. So because the game is symmetric, we only need to calculate it for 1. So now let's say we want to know the question when is playing aggressive paying higher payoff. Okay, so now we would solve the equation. Let's do it for firm 1. How we can do it actually for firm 2, it doesn't matter. So firm 2, when playing aggressive, gets 5 with the probability of P. And 7 with probability 1 minus P. Oops, I need to make that orange. So that is the expected payoff from playing aggressive. And we want to know when is playing aggressive paying a higher payoff, at what probability P. So that needs to be greater than the payoff associated with paying moderate. And then of course when playing moderate, firm 2 would get 0 with probability P. So 0 times P plus would get 8 with probability 1 minus P. Okay, so now we can solve. So here again to the left we have the probability, the expected payoff from playing aggressive, and to the right we have the expected payoff from playing moderate, and we want to know when is aggressive paying a higher payoff. This is what this equation says. So whatever P we get, it will tell us when paying aggressive has a higher payoff. So let's just solve. So we have here 5P plus 7 minus 7P. That needs to be greater than 0 plus 8 minus 8P. Okay, so now we have here negative 2P plus 7 needs to be greater than 8 minus 8P. Okay, so let's collect terms. So we have here, if we add on both sides AP, 8P, then we get here 6P plus 7, but I subtract that, so if 6P is greater than 1, or if P is greater than 1 over 6, then playing aggressive has a higher expected payoff. So that means playing aggressive has a higher Besson of attraction. So that means if we take a look at the spectrum from 0 to 1, okay, maybe here if we have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Okay, so here we would have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So playing moderate is only superior if aggressive is played with less than 1 over 6. But if let's make aggressive red. So the Besson of attraction goes from 1/6 all the way to 1. That would be the Besson of attraction for aggressive. And the attraction for the Besson of attraction for moderate, that is only 1/6. So that would be moderate. So that is actually an interesting result in conflict economics, which if you imagine we replace aggressive and moderate maybe with war with peace, then what that tells you is that to maintain an aggressive or war equilibrium is much easier than maintaining a maintaining a war equilibrium is much easier than maintaining a peace equilibrium. Why? A peace equilibrium is much more vulnerable to intrusions. So let's say, imagine you have two tribes that have a history of being at conflict with each other, but they are currently at peace. So they play aggressive with less than a probability of 1/6. So the moderate payoff is being realized. But now, because the Besson of attraction for aggression is so high, if let's say in the tribes where moderate is being played with a probability of less than 1/6, if there's an infiltration of aggressive warriors, then it is very easy to see that a peaceful situation can flip very quickly into a war-ridden confrontation. So the peace equilibrium is much more vulnerable to aggressive intrusions than what the war equilibrium or the aggressive equilibrium is to peace intrusions. But anyhow, so if we want to understand why certain tribes or countries seem to be permanently at war with each other, the question is actually they are most likely risk dominant. So the aggressive equilibrium is risk dominant, and aggression has a high Besson of attraction, and the episodes of peace or equilibria of moderate, they can easily be shocked and converted into aggressive behavior. So that's a little bit the story. So game theory is really important to understand, especially conflicts. But anyhow, let's just stop here and move then to the next topic, which is about evolutionary stability, which is a little bit related to the idea of intrusions of different strategies. But let's just stop here.